In this section, we're going to take a look at ellipses, and I'm in the formula sheet section of the course, and I'm going to go to the all exam formula sheet, and I'm going to go to the last page, and here we have the formulas for the ellipse. I'm also going to go into lecture notes, and in the lecture notes section, I'm going to go into section 6.2. And we're going to talk about an ellipse. And an ellipse is a set of points in a plane, the sum of whose distances from two fixed points is constant. Each fixed point is called the focus of the ellipse, and the plural of focus is called foci. If we take a look at the ellipse that's on the right-hand side, the graph of an ellipse is not a function. It's not a function because it would fail a vertical line test. Right? If you were to draw a vertical line, you would have more than one point of intersection, so that makes an ellipse not a function. The foci lies on what's called the major and the minor axis. So if we take a look at the ellipse that's on the right-hand side, notice that the longest part of the elliptical shape is the major axis. And on the major axis, we have the vertices and we also have the foci. So the vertices are plus or minus a comma 0. And the foci points are located at plus or minus c comma 0. The other axis is called the minor axis, and we can find the minor axis points at 0 comma b and 0 comma negative b. So in order to sketch out any ellipse, you would need a, b, and you would also need the value of c to find the foci points. So let's take a look at the actual equation of an ellipse. So again, we're going to talk about ellipses that are centered at the origin. On the formula sheet, that's on the all exam formula sheet, these are for the conics that are centered at the origin. Okay, however, if I go back to the formula sheets, we have a conics formula sheet, and these are for conics that are not centered at the origin. So back to the equation for an ellipse, we have the standard form, x squared divided by a squared plus y squared divided by b squared is equal to 1. This is the standard form of an ellipse, given that a is greater than b. So notice that a, the denominator under the x variable, would be the longest axis. So therefore, the vertices and the foci would be located along the x-axis. So it has vertices of plus or minus a comma 0. It has the endpoints for the minor axis as 0 comma plus or minus b. And it has the foci points plus or minus c comma 0. So notice that the vertices and the foci are located along the x-axis because under the x variable we have the biggest denominator. We also have a formula for c squared. C squared is equal to a squared minus b squared. An ellipse also can take this form, y squared divided by a squared plus x squared divided by b squared is equal to 1, where a is greater than b. Notice that the difference in the two formulas is that a would be the largest denominator, and it's located underneath the y variable. So on the y-axis, we can find the vertices and the foci. So the vertices here are 0 plus or minus a. The foci are also located on that y-axis at 0 plus or minus c. the endpoints for the minor axis are plus or minus b comma 0, and the formula for c squared is equal to a squared minus b squared. So here we're asked to graph this ellipse which is centered at the origin. So we have 4x squared plus 9y squared is equal to 1. So we're asked to graph 4x squared plus 9y squared is equal to 1. Excuse me, 4x squared plus 9y squared is equal to 36. I'm jumping a little bit ahead of myself. So the first thing we want to do is we want to put our equation in standard form. So for standard form, notice that we must make our equation equal to 1. So in order for our equation equal to 1, I'm simply going to divide everything by 36, because dividing by 36 will force a 1 on the right hand side. So next, I'm going to simplify my fractions. 4 divided by 36, that's going to give us 9. And if we reduce 9 over 36, that's going to give us 4. So now notice the form here, we're going to have x squared over a squared plus y squared over b squared is equal to 1, because the largest denominator is underneath the x variable. So from this point, we can set a squared equal to 9. So if we were to find a, we can simply take the square root. So a is going to equal to 3. We can also find b. All right, we can set b squared equal to 4. So just to show what I'm doing, I'm setting 9 equal to a squared and solving for a. I'm setting b squared equal to 4 and solving for b. So if we were to take the square root of both sides, b is going to equal to 2. So when I write out my equation in standard form, I have x squared divided by 3 squared plus y squared divided by 2 squared is equal to 1. Right, so now we're going to graph. All right, so since the largest variable is underneath the x-axis, and if we go back to our formulas, so here we have the largest denominator underneath the x-axis. We have the vertices are plus or minus a comma 0, and we have the minor axis points as 0 comma plus or minus b. So these are the 2 points we're going to use to sketch the ellipse. So I'm just going to go here for a second. Right, so if this is our model form, the vertices are located at plus or minus a comma 0. The minor axis points are located at plus or minus b comma 0. Excuse me, 0 comma plus or minus b. All right, so we have our vertices as negative 3 comma 0 and 3 comma 0. We have our minor axis points at 0 comma negative 2 and 0 comma positive 2. Right, so we're going to sketch these things out. So our vertices at plus or minus 3 comma 0. So we have a point here and a point here. And these are our vertices. And we're going to call those V and V prime. And then we have our minor axis points at 0 comma positive and negative 2, which are here. And we're going to call those B and B prime. And we're simply going to draw the ellipse. All right, we're also going to find the foci. And I'm just writing these out again. So in order to find the foci, all right, so here again, the foci is going to be located along the major axis, right, which is this x coordinate. So the foci are going to have the coordinates plus or minus c comma 0. Right. Well, how do we find c? Well, we're going to use the formula c squared is equal to a squared minus b squared. Right. So we know from our formula that a squared is equal to 9 and b squared is equal to 4. So c squared is equal to 9 minus 4. So in order to find c squared, we have 5. We're going to take the square root. So c is equal to the square root of 5. Right? If we were to decimalize the square root of 5, we have approximately 2.24. Right? So our foci are going to be located at negative 2.24 comma 0. Well, I'll just write it all out as plus or minus 2.24 comma 0. And I'm going to guesstimate a little bit here. So negative 2.24 would be approximately there somewhere. That's F. 2.24 is going to be approximately here somewhere. So we have our foci points. All right, so we found the coordinates for the foci. Next, we're going to look at ellipses that are centered not at the origin, but at some vertex h comma k. So here we have the standard form for ellipses that are not centered at the origin. We have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. So notice that the standard form for any ellipse is always set equal to 1. Both terms are added together. Keep in mind that for the vertex, H always follows the X coordinate and K always follows the Y coordinate. And we're given some additional information. We're given that the horizontal major axis has a length of 2a, and the vertical minor axis has a length of 2b. Right? So if we actually wanted to find the lengths of those, we can simply find a and b, multiply by 2, and that would give us the lengths for both the major and the minor axis. So now we're asked to graph this particular equation. We have x minus 2 quantity squared over 9 plus y plus 1 quantity squared over 16 is equal to 1. All right, so we're going to graph x minus 2 quantity squared over 9 plus y plus 1 quantity squared over 16 is equal to 1. Right, so the first thing we want to do is we want to pull out the vertex. Right, so our vertex, remember that the vertex is in the form h comma k, and when we pull our vertex from a formula, the signs always change. So the vertex here is equal to 2 comma negative 1. Okay, and we saw why the signs changed in the previous video. Next, we have to find the major axis points. So keep in mind, since 16 is the largest denominator and it's above the y-axis, our major axis is going to be along the y-axis, or we're going to have a vertical major axis. And then our minor axis is going to be horizontal or along the x-axis. Since our major axis is located is vertical, right, so we have a squared is equal to 16, so we have a is equal to 4. So that simply means from the vertex, I'm going to go up 4, I'm going to go down 4. So I'm going to go up 4, 1, 2, 3, 4. I'm going to go down 4, 1, 2, 3, 4. For our minor axis, that's going to be located horizontally. We have b squared is equal to 9. So take the square root, b is equal to 3. So from the vertex, I'm going to go 3 places to the left and 3 places to the right. So we have 1, 2, 3. 1, 1, 2, 3. And here is our ellipse. Okay, so this is our major axis. Okay. Excuse me, if we were to write out our major axis points, we would have 2 comma, and then I'm going to go, this point is actually 2 comma 3 and 2 comma negative 5. And for our minor axis points, we have negative 1 comma negative 1 and 5 comma negative 1, right, as our minor axis points. All right, now let's take a look at some other examples. So we're asked to write in standard form, and we're given 6x squared plus y squared is equal to 36. So we're going to write this in standard form. So I'm going to divide both sides by 36. Right, so if we were to reduce, we have x squared over 6 plus y squared over 36 is equal to 1. Right, so we have 36 is the largest denominator. So a squared is equal to 36. So if we take the square root of both sides, a is going to equal to 6. We have b squared is equal to 6. So if we take the square root of both sides, b is equal to the square root of 6. So I'm going to write this out as x squared divided by a squared. So a, or b squared, so b is the square root of 6. We're going to square that, plus y squared over 6 squared is equal to 1. So for our next example, we're given 25x squared plus 9y squared is equal to 1. We're asked to write in standard form. We want to find the major axis points. We want to find the minor axis points. And we also want to find the foci. Okay, so first let's write this in standard form. All right, so notice it's already set equal to 1, but I want to show you a trick with the calculator. Well, not really a trick, but all right. I'm going to write this in standard form as following. So 25x squared plus 9y squared is equal to 1. So I'm going to write out 25x squared as x squared divided by 1 over 25 plus y squared divided by 1 over 9 is equal to 1. Right. So notice I've taken the coefficients for both x squared and y squared, and I put them in the denominator. Okay, and I want to show you this. So we take a look at 25 in the numerator. Okay, so there's an understood 1 as far as being the coefficient of x squared. In my calculator, 1 divided by, and I'm going to use a set of parentheses, 1 divided by 25 is 25. Okay, so this is like a reciprocal trick. So that 1 divided by 1 over 25 is actually 25, just rewritten. And the same thing for our y variable. 1 divided by, in a parentheses, 1 divided by 9 is 9. All right, so these two equations are exactly the same. So the next thing I'm going to do is I'm going to pull out a squared and I'm going to pull out b squared. So notice that 1/9 is actually larger than 1/25. So a squared is equal to 1/9. So I'm going to take the square root of both sides. So I'm actually going to write this out. So I'm going to take the square root of a squared. I'm going to take the square root of 1/9. So for a squared, the square root, for the square root of a squared, the square root and the square cancel. I'm left with a. For the square root of 1/9, I can actually use the quotient rule for radicals and write that as the square root of 1 divided by the square root of 9. So I get 1/3. B squared is equal to 1 over 25. So here again, I can take the square root of both sides. So B is equal to 1/5. So I'm going to write this out as x squared divided by 1/5 quantity squared plus y squared divided by 1/3 quantity squared is equal to 1. Right, so this is our standard form. Next, we're going to find the major axis. So notice that for our major axis, the largest denominator is 1/9, which is underneath the y variable. So if we go back to our formulas, I'm going to use this second set of formulas because the largest denominator is under the y variable. So we have the vertices are 0 plus or minus a. The foci is located at 0 plus or minus c. And the minor axis points are plus or minus b comma 0. Right, so to find the major axis points, right, so again they're located at 0 comma plus or minus a. So we already figured out that a was 1/3, so our minor axis points are 0 comma negative 1/3 and 0 comma positive 1/3. We have our minor axis points, which are located at plus or minus b comma 0. And we have defined b as 1/5. So we have negative 1/5 comma 0 and positive 1/5 comma 0. And for our foci, we have 0 comma plus or minus c. So now we're going to find c. All right, so we have c squared is equal to a squared plus b squared. And we have a squared as 1/9 excuse me, that's a squared minus b squared. Thinking about the Pythagorean theorem. So we have a squared minus b squared. So a squared is 1/9. And I'm pulling that here. B squared is 1/25. So if we were to subtract 1/9 minus 1/25, we get 16 over 225. C would be 4 over 15. Okay, once we reduce. So we have our foci at 0, comma, -4 over 15 and 0, comma, +4 over 15. Right, so we have standard form of the equation. We have the major axis points, the minor axis points, and the foci. Okay, and we're going to look at one last example. Here we're asked to write in standard form, and we have 9x squared minus 18x plus 16y squared minus 96y plus 9 is equal to 0. So here we will be required to complete the square. So the first thing I'm going to do is I'm going to group my variables. So I'm going to group my x variables. I'm going to group my y variables. And I'm going to move the constant to the right-hand side. The next thing I want to do in order to complete the square, the coefficient of our squared term must be 1. So for our x variable, I'm going to factor out a 9. So I'm left with x squared minus 2x. And since I'm going to complete the square, I'm going to put plus blank here. For the y variable, I'm going to factor out a 16. So on the inside, we're going to have y squared minus 6y plus some constant. That's equal to -9 plus some constant plus another constant. Okay, so the reason for the blanks on the right-hand side is because what we add to one side, we must also add the other to the same side, the other quantity. All right, so let's complete the square for our x variable. So in order to complete the square, we had a proper form, and a proper form means that the coefficient of our squared variable is 1. So we're going to take the coefficient of the middle term, which is 2. We're going to divide that in half, and we're going to square it. All right, so 2 divided by 2 is 1, and 1 squared is 1. We're going to complete the square of the y variable. So we're going to take half of the coefficient of the middle term. So -6 divided by 2, and we're going to square that. So -6 divided by 2 is -3, and -3 squared is 9. So now we want to fill in the 2 blanks on the right-hand side. So now it appears that we added a 1 to both sides. We added a 1 here and a 9 here. But if we look at the multiplier of 9, if I multiply 9 times 1, I get 9. So I actually added a 9 over here, right? Because if we were to distribute, right, 9 times x squared is 9x squared. We started with 9x squared. 9 times 2x is -18x. We started with -18x. But 9 times 1 is 9. So that means we added a 9 to the left-hand side, so we must add a 9 to the right-hand side. Same thing for the y variable. Okay, it appears that we're just only adding 9, but if we look at the multiplier of 16, right, 16 times y squared is 16y squared. We started with that. 16 times negative 9y is negative 96y. We started with that. But 16 times 9 is going to give us 144. So we actually added 9 and 144 to the left-hand side, so we must also add those same things to the right-hand side. Now, since we've completed the square, we're forcing perfect square trinomials. So for this first term on the right-hand side, we have a 9. And once we factor the trinomial, we should have x minus 1 quantity square plus, so where I'm actually getting this negative 1 from is that when you take half of the coefficient of the middle term, so let me just make this correction. When we complete the square, we take half of the coefficient of the middle term. So the coefficient of the middle term is negative 2, and negative 2 divided by negative 2 divided by 2 is negative 1. So negative 1 is the magic number that you put here. Plus 16 times y minus 3 quantity square. So here again, this minus 3 comes from half of the coefficient of the middle term squared. Right, is equal to 144. All right, now if I put this in standard form, I'm going to divide everything by 144, right, because it must equal to 1. So now if we reduce, we have 9 times, or if we reduce 9 divided by 144 is 16. So we have x minus 1 squared divided by 16 plus y minus 3 squared divided by 9 is equal to 1. So we have 16 as the largest denominator, so a squared is equal to 16. That means a is equal to 4. So we're going to write that out as x minus 1 quantity squared divided by 4 squared. We have b squared is equal to 9. So if we take the square root, b is equal to 3. So we have y minus 3 quantity squared over 3 squared equal to 1. And this would be standard form for the equation. So here again, you must complete the square. And just as a reminder, on our home page, if you were to visit lecture notes, under chapter 6, there is a video on completing the square.